Welcome to the introductory lesson of our drawing unit. To start this unit, we're going to have to talk about scale drawings, and we have to get some definitions out of the way, and these definitions will pop up throughout the unit, so it's important that we know what they are right now off the start. The first definition is about a proportion. A proportion is just a statement of equality between two ratios or rates, and we'll just write down the definition, and we'll get to these throughout the unit, but it's important to know what each of these means. So proportion is a statement of equality between two ratios or rates. But there's two key words in that definition, one of them being a ratio. Now ratios you would have taken early in junior high and in some high school courses as well. But a ratio is a comparison between two numbers, but these two numbers have to have the same units. And again, we'll look at those. So if we're talking meters, they both have to be in meters. If we're talking centimeters, they both have to be in centimeters. So the units need to be the same in a ratio. But conversely, in a rate is a comparison between two numbers with different units. Now the rate you'll be most familiar with is like the speed of a vehicle, kilometers per hour. We're comparing how far you go in kilometers and how long it takes you in hours. Or the second one that I wrote there is meters per second, another speed. So you can run this many meters in this many seconds. So we're comparing those two different numbers. So we're going to start using these definitions in this lesson and in lessons that follow. So we'll look at the first example here. Example 1 says, the ratio of length to the width of a rectangle is 5:3. So this right here is the ratio, 5:3. If the rectangle is 24 meters wide, how long is it? Now it's really important that you can read and decipher what this information is telling you. First off, they're saying ratio. So ratio, if you look at your definitions, a ratio means the units are the same. So 5:3 would mean 5 centimeters. If the length is 5 centimeters, the width would be 3 centimeters. Or if the length was 5 miles, the width would be 3 miles. But in this case, we're talking about centimeters. Now again, we said ratio, so the units are the same. And this statement here is really important. It's saying the length to the width. So this is why this arrow is going to the first one. That's my length to the width. The second one is my width. So if I was to set it up, I could say another way to write this is length to the width. Well, 5 for a length, 3 for a width. And now we can set up an equivalent proportion where we're saying if the rectangle is 24 centimeters wide, so here we could say, okay, equals, and the width is down here on the bottom and it's saying 24 centimeters, so it's important that the 24 goes in the same spot as the width. So if it's saying if the width is 24, how long is it? So I'm actually looking for this part of this fraction or this proportion. So to get the answer here, this is where we have to be pretty well versed in cross multiplying. So to cross multiply, we can draw this cross to the equal sign, and we look at the stick or the part of this cross that has two numbers on it. That's the multiplying part. So it's 5 times 24, and then we divide by the lone number, which in this case is 3. And if we did this operation, that would tell me what this question mark is in that proportion. So 5 times 24 divided by 3, if you do that on your calculator, we get 40 is our question mark. But because we're in a unit of drawing, we're going to have to make sure we have the units, the right units. So this is in centimeters, so 40 centimeters. So what this tells me is that the length of this rectangle, given that its width is 24, has to be 40 centimeters. So again, it's coming down to a lot of reading comprehension and knowing how this ratio is talked about. So we're going to look at two more definitions here. A scale statement. Now a scale statement is a ratio that shows the relationship between two sizes of objects. And we're going to start looking at this like a map. A map is just a shrunk down version of an actual scenario, an actual land mass. So when we're doing scale statements, we always compare the drawing to the original. It's always in that order. And you'll hear me, how I refer to it with a lot of my students, drawing to original, and I say, well, it's Dr. Orr. So if you can remember Dr. Orr, it's always drawing to original. So I can give you a scenario here where I say, well, 3 centimeters on the drawing is 7 centimeters in the original. So what this means is I'm actually drawing something a lot smaller because my drawing only has 3 centimeters when the original was actually 7. A different way I can look at it is saying, well, maybe 1 to 15. That's another smaller version. So 1 centimeter on my drawing is actually 15 centimeters in actuality. Or I could be saying 1 mile is actually 15 miles on a map. If I switch those around and said 15 to 1, this means something entirely different. What this is telling us is that 15 centimeters on my drawing is actually only 1 centimeter originally, or in the actual image. So we actually made this thing bigger in our drawing. So now if we look at a scale factor, the scale factor is just the number that you'd actually multiply by to get the enlargement or the reduction. So if I looked here, the scale factor would just be 3/7. That's what I'd multiply by to get what it would be in the actual drawing. Here, I'd multiply by the fraction 1/15. Here, I'd multiply by 15/1, which basically just equals 15. So the scale factor is just the number by which all the dimensions of the original figure are multiplied to produce the drawing. Which brings us into our next examples. And it says, write a scale statement for the reduced or enlarged object and calculate the scale factor used to create the reduced or enlarged object. So if I'm looking and I look at the words, which are important, this is model. This is what we're actually drawing. So this is my drawing. The original, well, that's my original. And remembering that we always said it's drawing to original, or, which I'll probably refer to from here on in, like this, drawing to original, which is Dr. Orr. Now we got to make sure we're comparing the right thing. So 3 centimeters on this drawing, so 3 centimeters, is 6 centimeters, the bottom line of the original, 3 to 6. So we actually did draw a reduced figure. We actually made something smaller. Now this is the actual scale statement, but when we come down, we could reduce this just like a fraction. 3 to 6 is the same thing if I divide both numbers by 3 as 1 to 2. Now this 1 to 2, this would be my scale statement. Which means my scale factor, we're saying if I knew my original diagram and I needed to get this number, what do I multiply by? Well, the scale factor is close to the ratio, it's just 1/2. So if I was to multiply 6 by 1/2, I'd get 3. That's my scale factor. So there is a connection between these two. And remember, the scale statement, this had the same units on it, the 3 to 6 or the 1 to 2. So now let's look at these three-dimensional cubes. And we're saying, again, here's my original, so that's original. Here's my model, or as we call it, the drawing. Remember that the scale statement is going to be drawing to original, Dr. Orr. If my original is this small cube, and the model's actually bigger, this is an enlargement. So we're making something larger. On my drawing, I need to choose a side that lines up with the other one. So if I choose this height of 10, I have to make sure I look at the height of the little guy. So the drawing has 10 centimeters for the height, and the original is only 2 centimeters. So that's a scale statement, but we can reduce this by dividing by 5 each dividing by 2 each number So 10 divided by 2 is 5. 2 divided by 2 is 1. This would be my scale statement, which means if we try to interpret what we're actually saying here, is that on my drawing, anything that's 5 on my drawing is actually 1 on the original diagram. So we made our drawing bigger. Anything 5 is actually 1 on the original. So that's my scale statement. The scale factor now is saying, what do I have to multiply each dimension by in this original little cube to get the dimension on the drawing we did? Well, the scale factor comes right here from the scale statement. It's like 5 over 1, which is really 5. So my scale factor just says if I have anything on the original diagram and multiply it by 5, I know how long to make it in my diagram. So scale statements, scale factors are related. And let's look at the last example here. A man in a photograph is 2 centimeters tall. His actual height is 1.8 meters. And we want to come up with a scale statement, and we want to come up with the scale factor. So the photograph, this is my drawing, or what I'm creating, and this is his original height. So remembering the drawing to original, or Dr. Orr. Now it just as a scale statement, so there's 2 things we can do here. We could say 2 centimeters in the drawing is 1.8 meters on the actual man. So this would be one scale statement. Another thing that we could say is, well, we know that 1.8 meters, we should know from grade 10, this is 180 centimeters. So another scale statement I could say, if I needed that as a ratio, is 2 centimeters on my drawing is actually 180 centimeters in real life. And both of these, if I reduce to lowest terms, to 1 to 90, this is my scale statement. I can divide both of those by 2, which means, again, if we consider this being drawing to the original, on the photograph, anything that is 1 unit long, in actuality, is 90 of those same units on the real person, so 1 to 90. So now the scale factor we just say, well, 1 to 90, so that's 1/90th. If I multiply anything on this man by 1/90th, I would get how long it is going to be in the photograph. So for example, a simple calculation, if we said like his arm is 90 centimeters long, if his arm is 90 centimeters, and I multiply that by 1/90th in my calculator, well, that would end up being 1 centimeter on the actual picture. If something was 270 centimeters long, if I multiplied it by 1/90th, that would mean in the photograph it would be 3 centimeters. So the scale factor is something we can multiply by to get how big it would be in the picture.